Now let's have this problem here. Bentong pushes his 30-kilogram grocery cart by a force of 300 Newton, inclined an angle of 55 degree with a horizontal through a distance of 5 meters. Assume that the coefficient of kinetic friction is 0.30. So here are the questions. First, you have to create a free body diagram. Then, find the horizontal component of the force. Find the vertical component of the force. D. Find the work done by 300 Newton force. Find the amount of friction force. And last, find the work done by friction. So it seems there's a lot of questions here or tasks, but let's answer these one by one. Let's go to the first task, okay, which is to create a free body diagram. So Bintong pushes his 30-kilogram grocery cart by a force of 300 Newton, inclined an angle of 55 degree. So we will have to draw an arrow, okay, and this would be the applied force, okay, which is 300 Newton, okay, and it's inclined an angle of 55 degree through the horizontal. So here, the angle here is 55 degree. And then, as it moves, okay, it has a friction, and then this cart here has also weight. And then, it has a normal force. And then this is the movement of the cart going rightward. So this is just a rough illustration of the free body diagram. But let's go to the standard form. So first we have to convert this cart into this box here. And then the cart has a mass and it's in the earth and it's subject to gravitational force, so therefore it has a weight. And then it's not falling down, so that it must have some sort of normal force. And then this man applied a force which is 300 Newton, inclined an angle of 55 degree. Okay, and as he applies force, the cart moved in the rightward direction around 5 meters. Okay, as it moves, it has or it gains friction force. Okay, but again, we will not end with this free body diagram because remember, this applied force here is inclined an angle of 55 degree. So we have to break this down into components, meaning what component in this force that um, belongs to vertical and that what components belongs to horizontal. So we do this. Okay. Now we're done creating the free body diagram. Let's go to letter B and letter C, which is letter B. You have to find the horizontal component of the applied force. Okay, and you have to find the vertical component of the applied force for letter C. So what do we mean by this? So here, okay, this is the vertical component. This is the C, and then the horizontal component, letter B. So how to answer this kind of problem? Okay, so here for the vertical component, you use F sine theta. And for B, you have to use the F cos theta. But why? So let's have a review first about the SOHCAHTOA. In the previous WLP, we tackled about the free body diagram and the first law of motion, which is the law of inertia. Now let's look back and relearn it because these things are important so that you would understand the next concept.
Okay, today we are going to learn what is SOHCAHTOA. It's a little mnemonic that we're going to learn to help us to determine which trigonometric ratio is appropriate for a specific problem. Now the word trigonometric is kind of a big word. We are a lot of times going to instead just say trig. We're going to call them trig ratios, and that's just short for trigonometric. Trigonometry is actually the study of right triangles. So knowing that, let's look here at a right triangle. Introduce here, we've got this little funny symbol here, which is called theta. And it is an angle, angle theta. I could have put that up here. In fact, we're going to do that in just a minute. But any of the angles can be called theta. We've got a lot of different letters. These are the Greek letters that we use for angles when we do trigonometry. So notice it is an angle and it's not one of the sides. Okay, so looking here, we've got three new, these are trigonometric ratios. The trig ratios, the basic ones that we're going to talk about today, are sine, cosine, and tangent. So it's sine, cosine, and tangent. That's their official names. And for short, we call it, we write it as SIN, but we don't say sin theta or cos theta or tan theta. We still say sine theta, cosine theta, and tangent theta. But we write it this way to make it simpler. So having said that, let's get back to what do they mean and what does SOHCAHTOA mean? Well, these are ratios. It doesn't look like a ratio. A ratio is supposed to be one thing over another. So we need to figure out what are the things that are going to be, sine theta is going to be equal to something over something else. So when I want to know what that is, that's what I need that mnemonic for, that SOHCAHTOA. Okay, and you got to remember how to spell these, or it doesn't work. No, doesn't work. It's no good if you can't remember how to spell SOHCAHTOA. So notice here we've got an S in so for sine, and we've got a C in ka for cosine, and we've got a T in toa for tangent. And then it's going to be that the O and the H are going to be here and here. So O and H, and this is going to be A and H, and this is going to be O and A. So let's just figure out what is O, what is A, what is H. And it's not, when I say A, I don't want you to be confused here. It doesn't mean this A over here. So looking at this, O, relative to theta, O stands for opposite. Opposite. We want to know what is the side that is opposite this theta. So O stands for opposite. H, on the other hand, stands for hypotenuse. Okay, hypotenuse. Okay, here, ka, the A stands for adjacent. Adjacent is just a fancy word meaning next to. So the leg, and the adjacent is always the leg because it can't be the hypotenuse. Okay, so cosine is the adjacent. It's the ratio of the adjacent side over H, again, is the hypotenuse. And then toa, tangent, is the opposite over the adjacent. So we have, and yes, if you can hear that, that's my kids in the background. So adjacent here. And we're going to use these to help us solve problems. Problems where we are given an angle and one of the sides and we need to find another side, okay? That's when we use that. Remember, we used the Pythagorean theorem when we are going to use, when we have two sides and we need to figure out the third side. But when I'm given an angle and a side and I need to figure out an other side, that's when I use SOHCAHTOA, sine, cosine, and or tangent. Okay, so looking at this same problem, I could, if I wanted to, decide to move, and let's make this theta for this problem, okay? Doesn't change anything. except for my reference point. Now, instead of A being the opposite side, now A is the adjacent side. And B is my opposite side. And C is my hypotenuse. So if I was actually going to, instead of writing adjacent, hypotenuse, and opposite, if I was going to actually write these letters, A, B, and C, in its place, what would I write? Okay, I've got sine, that's so. So S, O, and H, my opposite side from theta, my opposite side is B. Okay, so actually I shouldn't have written that there. I'm going to erase that because that's just going to confuse us. My opposite side is B, and my hypotenuse side is C. Oh goodness, I'm goofing up right and left here. Okay, and then here for cosine, cosine equals ca, adjacent over hypotenuse. So my adjacent is A, and my hypotenuse is C. And the tangent, tangent equals opposite over adjacent, TOA. Opposite is B, the adjacent is A. So if I had numbers in one of these places and then I had this angle, that's how I would set up an equation that I could then solve. Let's look at that. Okay, so here I have an example problem. I have this angle here. This is my theta. So I need to know what ratio do I use if I know this is my angle, this is the side I know, and this is the side I want to know. What I have to do is I have to identify. Obviously, because this is across from the right angle, this is going to be my hypotenuse. So I'm definitely going to want one of the ones that has the H in it. So either so or ka. So again, I've got so, ka, toa. So because I'm using H, I've got a hypotenuse here, I know that toa is not going to be the one I'm using. So I need to identify, compared to this angle, where is this 7? 7 is the adjacent side, okay? Because again, this is the opposite. I don't know anything about the opposite, so the opposite can't help me. So I want to use the trigonometric ratio that has the A and the H. That means I'm going to use cosine. So I would just write an equation that looks like this. Cosine of 35, or I could make that shorter. I could just write cosine of 35 equals the adjacent is 7, and the hypotenuse, I don't know, is C. And now I have one equation and I have one unknown, and we'll learn about tomorrow how do we actually get a number for that. But I've got one equation and one unknown, I can solve that. So that's basically how we use SOHCAHTOA to figure out which one of the trigonometric ratios I want to use when I've got a problem. Let's see, do I have, oh, I don't have any more problems. So let me make one up here. Let's make one more up. Okay, let me get a triangle. This triangle's going to look just like the other one, but that's okay. And this time let's use this angle. I'm going to call that a 56-degree angle. And let's say you knew this side was 12 and you didn't know what this side was. We'll call this x. Which trigonometric ratio would we use? Okay, here's my angle. That's the first thing. Where's my angle? Identify where your angle is and then figure out which sides you have. So we've got the opposite over here. So I want one of them that has an O in it. And here, this one is the adjacent side. Here's my hypotenuse. I don't know my hypotenuse, so it can't help me. So I need the trigonometric function or a ratio that uses O and A. So out of so, ka, toa, the one that has an O and an A is toa. So I want to say the tangent of 56 degrees is equal to the opposite, which is 12, over the adjacent, which is x. And there I have one equation, one unknown. I can solve that, and we'll learn how to solve that tomorrow. I hope that helps. Thanks a lot.
So hopefully by now you already know why we use sine theta for vertical component and we use cosine theta for horizontal component. Something to do with the trigonometric functions. So if you will to identify each part, this will be the hypotenuse because it has the longest side, and this is the angle. Okay, this is the angle. Opposite to that angle is the opposite. And then this one would be the adjacent because it's tapad. Okay, so if you want to know the value of this one, the opposite, you just refer to this mnemonic, so katoa, okay? And then you look for O, so this one has O, okay? And you look for the side that has a value. In this case, the hypotenuse has a value, which is the 300 Newton. The adjacent here doesn't have a value, so we will have to use this one, so H. So we're gonna look for H and hit here. Okay, so the mnemonics that has two checks, okay, here it doesn't have value for adjacent, so if it has two checks, then we will use this one. That's why here for finding the opposite, you have to use the sign. So notice letter S here, sign. And in finding the value of the adjacent, okay, you just simply look for letter A here. It has letter A. And then look for the side that has already a value. In this case, we have the value of the hypotenuse, so H. It doesn't have a value of hypotenuse, so it has two checks. So therefore, we can use the cosine. That's why it's cos here. Letter C here stands for cosine. So we proceed now to letter B, which is to find the horizontal component of the force. So this is the force. Okay, it's inclined an angle of 55 degree. We will look for the horizontal component. Okay, so this is the horizontal component. Yeah. So we will use the F cosine theta. So the horizontal component, horizontal stands for or symbolizes x here, is equals to F cosine theta. We do have the value of the F. You just plug in the cosine and then the angle. So this would be just plain substitution. And then you get your calculator. Okay, we have it here. How to type? 300, then cosine, then 55. And you get this number here. So out of the 300 Newton force, the horizontal component is 172.07 Newton. Okay. Next, how about the vertical component or the Fy? Okay, so we already identified this one that we'll have to use the sine theta. Okay, just plain substitution. And then sine, then the angle is 55 degree. So let's get our calculator here. 300, then press the sign, then 55, and you get 245.75 Newton. Okay, so basically the value of the vertical component of the force, and it's going downward, is 245.75 Newton. And the value of the force going horizontally, going rightward, is 172.07 Newton. And if you combine these two in with the respective direction, you will get this one.